Now the bad news. After practicing all of those input and output charts, Lesson 4.3 is going to teach you quick graphs. A quick graph means that we're going to just use the intercepts to be able to make our linear or make our line, our graph our line. So you can pause if you want to read all of that. I'm going to go ahead and keep going. So I have an equation, a linear equation, 2x plus 3y equals 6. Now, in order to find two different points on my linear equation, I can find the x-intercept by letting y equal 0. I just want to know where it crosses the axis going left or right, so that would be my x-intercept. And the way I'm going to do that is substitute 0 in for y. So I would have 2x. Now my plus 3y would be plus 3 times 0, which is 0, equals 6. So x is going to equal 3. My coordinate point then would be when x is 3, then y is going to be 0. To find my y-intercept, I'm going to let the x be 0. I don't want to move left or right. I only want to move up or down. So 2 times 0 would cancel that out, plus 3y. So now 3y equals 6. Divide that by 3. My y is going to equal 2. So in that case, x was 0. And when I substituted that in, y turned out to be 2. Now let's see what we have hidden over here. Whoops, that wasn't right. I guess I need to be picking out the cursor. And now let's try to pull those out. We have 3, 0, and we have 0, 2. Okay, going to the next page. If I go ahead and plot those points, there's my x-intercept. Back to my pen again. There's my x-intercept. There's my y-intercept. I would connect those points, and I would end up with a linear equation. I would graph a line. So if I'm going to use intercepts to graph equations, I'm going to make a quick graph. So it says, graph the equation 3.5 plus 7 equals 14. In order to do that, I'm going to do just like I did on the last page, and I'm going to substitute. If I'm going to substitute that y equals 0, so my coordinate points will be something 0, it's going to cancel out my 7y, so I would have 3.5x equals 14. Whoops. I need to divide both sides by 3.5. And when I do that, oops, let me do a quick little cheat here to get the calculation done. When I do that, I'm going to end up with that x equals 4. So my first point that I would graph would be 4, 0. If I look at the next one, this time I'm going to let x equal 0. So in my coordinate points, it's going to be 0 something. So if I substitute the x as 0, that's going to take out my first term. So now I have 7y equals 14. I think I can do this one without taking a peek at calculations. So y is going to equal 2. So my other point is going to be 0, 2. If I use those 2 points, I can go ahead and I can, looks like I got to change select that again and change the transparency so that you can see it. There the points are, 0, 2, and 4, 0. And we can go ahead and connect those for a linear equation to create that graph line. Now, to graph the equation y equals 4x plus 40, first of all, we're going to find those intercepts. So to do that again, I'm going to find when y is 0. So this time you'll see that my equation has y equals. So I'm going to go ahead and I'm going to substitute, go back to my pen again. So 0 equals 4x plus 40. I'm going to get my x by itself, so I'm going to subtract 40 from both sides. So this time I had to put the 0 in because it wasn't used as a coefficient. Now I get negative 40 equals 4x. So if I divide both sides by 4, I'm going to get that x equals a negative 10. So my point would be negative 10, 0. Doing the same thing, I'm going to substitute x as 0. This time, there's a coefficient there. So now I have that y equals 40. I lost my x term completely. So this one would be that when x is 0, y is 40. Now you notice we have a big difference between those points. When we have a difference like that, this is when we need to figure out the tick marks, or how we want to graph this equation. So because they're so far apart, I'm going to go ahead and use an appropriate tick mark value of tens. Make sure your x-axis and your y-axis go by those that same kind of tick mark increments. So each line on my graph is going to equal 10. So when I do it that way, then I can make my graph in a relatively smaller area for a large span between the x and y points or intercepts. Now example 4 is just going to show you how to write and use a linear model when we are talking about real life situations. So this is a zoo fundraising. So again, problem solving, and they're going to help you with a verbal model here. You're organizing the annual spaghetti dinner to raise funds for a zoo. Your goal is to sell $1,500 worth of tickets. Assuming 200 adults and 100 students will attend the dinner, how much should you charge for an adult ticket and a student ticket? So you have an approximation of how many people you're going to serve. So we're going to go ahead, and the number of adults, we're going to fill that in. We know that is going to be 200, but we don't know what our price is going to be yet. So we're going to leave that as X. Now the number of students is going to be 100, but we're going to have a different price for the students' ticket price, so we're going to add a different, or use a different variable. So there's a Y. And then we know that our goal is to reach 1,500. Now we have a linear equation again. We have an X value and a Y value. We can take our quick method to be able to graph this. So we're going to substitute in our zeros. I'm going to find X first. So my Y is going to be 0. So that means 100 times 0. That's going to knock that term out. So 200X equals 1,500. If I divide both sides by 200 then, I can show you that, 200X, 1,500 divided by 200. 2 goes into 15 7 times. We're going to get 7, ooh, that's ugly, 750. Okay, if I do, so this is going to be 7.5. If I use 0 as my X value, I'm going to get 100Y equals 1,500. This one's a little bit easier. And I'm going to get that Y would equal, and if I divide by 100, oh, what did we do wrong there? If I divide by 100, I'm going to get that the students would have to be $15. Okay, so if I'm not going to charge anything for the, oops, sorry, let's fill this in. If I'm not going to get any adults there, the student prices are going to have to go all the way up to $15. If I don't charge anything for the students, then the adult prices will have to be $7.50. So this equation has many solutions. So to get a better idea of all the possible solutions, we're going to go ahead and make a quick graph. So those are made already. I just have them hidden from you. Here is my quick graph. So you can see that both of the values that we just worked on We have our $0 for the adults, means that the students have to pay a whopping $15. But the students don't pay anything, then we have that the adults would pay $7.50. As we graph these, then, we will see that one reasonable price uh, to charge is, let's go ahead and charge $6 for the adults and $3 for the students. We want the students' price to be less than the adults' price, and that's traditionally how we see that. So this would be, we don't want them to be free, but we could go ahead and make it a $6 and $3 difference. When I graphed it, I could see that this was a good possible solution. And that concludes 4.3, which concludes the intro to graphing linear equations.